So we're going to picture a situation right now where someone develops a lesion in their right vestibular apparatus and try to predict the nystagmus that will result from this situation. So there are a couple of things that we need to acknowledge before we really think about it, some basics that we need to understand. And the first is the effect of each vestibular apparatus on the eyes. And in the horizontal plane, at least, what's happening is that the right vestibular apparatus is trying to push the eyes to the left, and the left side is trying to push the eyes to the right. So each vestibular apparatus is trying to push the eyes in the opposite direction. What happens when someone's looking straight ahead and the eyes aren't moving to the right or to the left? So the mistake would be to think that both apparatus are quiet and that they're not active at all. That's not the case. There's actually seems to be a tone that's always present. And the reason the eyes are not moving is because the tone is balanced out. In a similar analogy here, I'm holding a pen in my hands. And the fact that the pen is not moving to the right or to the left might be because I'm not pushing with either hand. But it also could be that I'm pushing very actively with either side, but I'm just pushing with equal forces from each hand. And obviously, if suddenly my right hand loses strength, then the pen is going to move to the right because the left hand has now become dominant. It's not because the left hand became stronger, it's because the right hand became weaker. So in a similar sense, if when someone's trying to look straight ahead, all of a sudden there's a lesion on the right side, then what happens is that the baseline tone that was matched between the two sides, there's now a mismatch, not because the left side has become stronger, but because the right side has just become weaker. Because the right side has become weaker, now the left is dominant, and now the eyes will be pushed over to the right side. And this is the first thing that we need to understand. So it's not going to surprise us that in a situation like this, that there's going to be always this push that the eyes are experiencing over to the right. As a matter of fact, just as a side note, a lot of times when this happens in a patient, you can show this through an effect called Lateropulsion, where you have the patient close their eyes, and then you tell them to open up their eyes and look straight ahead. And you'll consistently find that when their eyes open up, that the eyes have deviated over to one side, and that would be the side where the lesion is, and then they'll quickly come back. This patient has a right-sided vestibular lesion. When he closes his eyes, the eyes drift to the right side. When he opens them up in order to look straight ahead again, the eyes quickly snap back in a left direction. So when a patient has this sort of situation going on, and they're trying to look straight ahead at a target, they have this battle going on. On the one hand, there's this constant drive that's trying to push the eyes, in this case, to the right, and then the brain keeps trying to overcome it and bring the eyes quickly back on target with a saccade. And this creates this constant pattern of slow movement off the mark and quick movement back on the mark. Slow movement off and quick movement back on. And this is a jerk nystagmus with the slow pathologic phase that takes the eyes off the target and a quick saccade that brings the eyes back on target. So that we can think of the saccade as really the good guy here. We often define the nystagmus in terms of the movement of the saccade, the quick phase, but it's actually the physiologic appropriate response that occurs. The pathology is really in the slow movements. So again, in this patient's case, we're going to see a nystagmus where the eyes drift off and come back. They drift off and come back. Now, what's going to happen when the patient looks off to the right or to the left? How is the nystagmus going to be affected? And according to what's known as Alexander's law, we would see that when the patient's looking to the right, that the nystagmus will dampen down and almost become nothing. However, when the patient looks off to their left, the nystagmus will become amplified and become much more significant. Why does that make sense? Well, let's first consider what happens when they look off to their right. And that would be analogous when I'm looking straight ahead to me turning my head now to the left, while my eyes are looking to the right. So the pathology, again, wants to keep pushing the eyes over in this direction. So let's say that we give the pathology what it wants. We have the eyes look fully over to the right. Now, in that case, there's still this drive that wants to push the eyes to the right, but they've gone as far as they can go. There's no further for them to go, so the eyes can't go any further to the right. So from that perspective, they're standing still. And then there's no need for a corrective saccade, so there won't be any movement from that perspective either. So in this situation here, where the eyes are looking all the way over to the defective side, you neither have any more pathological movement nor any corrective movement, and the eyes are still. On the other extreme, if the eyes are looking all the way over to the left, now there's tremendous drive to push the eyes to the pathologic side, to the right side, and you're going to see very much the pathologic drift to the right and a corrective saccade to the left. So we have a situation where we have this nystagmus, which beats in one direction, and in this case the nystagmus is beating to the left in terms of the fast phase, where there's an asymmetry that the nystagmus dampens down when the patient looks to their right, to the pathologic side, and it augments when they look to the left, to the still healthy side. And what would be in some ways tricky about this is that the nystagmus would be defined as a left beating nystagmus, but we should remember that the way that it's beating is a little bit tricky. It's beating towards the normal side and away from the pathologic side. And this is what's known as Alexander's law. Let's have a look at an example of a vestibular nystagmus that respects Alexander's law, complements of the University of Utah. So we have a marked left beating nystagmus in the left gaze. When the patient looks to the right, the nystagmus completely dampens down, and it's intermediate left beating when looking straight ahead. We're just having another look at this again. And so this patient would have also a right-sided vestibular lesion that corresponds with Alexander's law.